Доброе утро, добрый день, добрый вечер. В первых надо сказать scientific notation. Может быть, лет 20 тому назад в действительности я жил в Прибалтике, особенно в городе Риге. Так что я прошу прощения, если мой акцент так плохой, так обидно. Но я вам желаю счастья и здоровья, и, конечно, материальное благополучие. Давайте начнем.
Scientific notation means a different way of writing numbers. So this is a different language for numbers. It may look different, it may smell different, but they're the same thing. So we have standard notation, a bunch of digits combined to make a number, and then scientific notation. The components are we have a nice number that's less than 10, and it's being multiplied by 10 to the power of 2. Now, this looks like a giant math problem, and it is, but this is the way you write the number. So 123 equals 1.23 times 10 to the 2. But why do you even write these numbers like this? Why would I write 1,230,000, 1.23 times 10 to the 6? Well, there's a couple of advantages of writing and learning the language of scientific notation. Number one, it equals the standard form but can be rounded to satisfy the rule of significant digits. That means that if I needed this number, if I needed 123 and I needed to write it in only one significant digit, I could write this 1 times 10 to the power of 2, and this would only have one significant digit and satisfy that rule. So that's a really big advantage of scientific notation. The other one is we can manageably write gigantic or microscopic numbers in a nice way, right? We can express these numbers. So for example, here's this one. Avogadro's number is something we use in chemistry sometimes. It's a gigantic number. Written like this, it seems pretty small. That's nice, 6.022 times 10 to the 23. But if we were to write it in standard notation, kablamo! That's a big number I don't want to put into my calculator all the time. And if I'm using this in chemistry, forget it. So, scientific notation, the key is this, the exponent. So what does that do? The secret is 10 to the power of whatever is telling you decimal directions. Let me show you this. So this example, 3.14 times 10 to the 2. Well, what is 10 to the 2? We look over here, 10 to the 6 is a million, 10 to the 5 is 100,000, 10 to the 4 is 10,000. And we could find a table, but understanding this is even better. You know that an exponent, you could say, okay, fine. 10 to the 6 is 10 times 10 times 10 times 10 times 10 times 10. Or 10 multiplied by itself 6 times. And you punch that into your calculator and it wastes so much time you get a million. How about you just write 1 with 6 zeros? Oh, there's a 1 with 1, 2, 3, 4, 5, and 6 zeros. 1 with 5 zeros, 100,000. 1 with 4 zeros. 1 with 3 zeros. That's 1,000. 10 to the 3 is 1,000. So 1 or 10 to the 2 is 1 with 2 zeros. It actually means 100. So I could rewrite this equation 3.14 times 10, 1 with 2 zeros, which is 100. And you could totally equal this as 314. Standard notation, scientific notation. Now, I know it looked like I just solved a math question, but that's what it is. This is how you write numbers scientifically, multiplying it by a 10 to the power of something so we have a manageable number. Negatives are all the inverse. This is bizarro land, right? So we can do the same thing. Instead of 1 with 6 zeros, this is 6 zeros and a 1. 1, 2, 3, 4, 5, 6 zeros and a 1. Just make sure that decimal goes there. So 10 to the negative 3 is 3 zeros and a 1. That's 1,000th. Or 2 zeros and a 1. That's 100th. How about 1 zero and a 1? That's 1/10. And of course, this is just 1 with 0 zeros and 1 with. Let's complete the whole thing. So we're going down in exponents and going up in exponents kind of deal. Well, we're all going down really, but like you can see that the number hugeness gets bigger and bigger. If scientific notation means that we're just multiplying it by one of these exponent number things, and we already know the secret way of writing it down. Like I could write this down 3.14 times, this is Bizarro, so it's inverse, 2 zeros and a 1, 100th, or multiplying it by 1 over 100 if you want, that's the same thing, then it kind of makes it easier. Kind of makes it simple. I'm like, okay, fine. And if you know the secret, it's decimal directions. So what does this mean? Like, it looks like times 100 was easy, but what do we do for this one? Well, let me show you. Decimal directions in perfect color-coordinated scientific notation or standard notation to scientific notation fashion in blue. So here's my example 25.1. Step 1. Write down the standard number, this one, with the decimal place between the first and second significant digits. Now, in this case, if you need to make sure that you have a specific number of significant digits for your answer to follow the rule, then you would do that. I'm not doing that right now. So I'm going to rewrite this number, the standard number, 25.1, this way, 2.51. Jolly good. That is step 1. Step 2, probably the hardest one. I need a fancy pen for this too. Write down times 10. Okay? Because all we're doing is converting from standard notation to scientific notation. Step 3 is a big one. I'm just going to cancel this shade. Count how many decimal places and in what direction you'd need to move the decimal to get back to the original standard notation. Here's where I need to put a little warning to you. Some sites on the internet, they want to take this number and put down a decimal direction according to this number. I am always going to be looking at what the exponent does. Here, I'll go to the other screen. I will always be looking at what does this exponent do to this number. It's really important to understand it. This is how you read. This is how you read the scientific notation. What does this exponent, 10 to the power of whatever, do to this decimal number? 2.51 times 10 to the what? I need to get back to this. Now, we have put this decimal here, as you can see. I would need to move this, if it's here now, one place to the right. One place to the right. This is important. So, however many places you have, write that number as an exponent of 10. So I would need to move this one place to get back to the original number, so that's 1. And because I moved it to the right, that's a positive integer. And so I'm not going to write down the plus. You wouldn't write it down. It's already assumed positive. If you move the decimal to the left to get back to an original number, which we didn't do here, but if you move it to the left, then it would be a negative integer or a negative exponent here. Okay, so this is actually the completed product here. 2.5 times 10 to the 1 equals 25.1. That is scientific notation. So what about scientific notation back to standard? This is where it all comes together. So this is the most important part to really focus. I have this number, our components of scientific notation, a number under 10, and I'm going to multiply it by 10 to the power of an unknown fraction. If 10 to the power of 4, which equals 10,000, you could put down 2.689 times 10,000, and I'll give you standard notation. Or you can just say, okay, fine. This means 4 places, move this decimal right here, 4 places, and because it's positive, to the right. 1, 2, 3, and 4. The decimal goes here, and we're going to fill in this blank with a 0. So our answer is 26,890. That is standard notation. We have moved the decimal place 1, 2, 3, 4 places. It's right there. We don't usually need to write it, but that's it. How about this one? Again, decimal directions. That's all scientific notation does for you. Move the decimal, move this decimal 3 places to the left. See that negative? 3 places to the left. So I'm going to move this 1, 2, and 3 places, and I'm going to fill in these gaps with zeros. I recommend strongly that you always put a 0 on the left-hand side of a decimal when there's no numbers there so you can clearly see the decimal. So our answer is right here, 0.0067. So again, my method of standard notation says this times 10 to the whatever. This will tell you what direction. Left is always a negative direction. Right is always positive. That's really important for physics, so let's keep that in our understanding of scientific notation. Now, the last part about scientific notation is understanding how to work your calculator. Look at these. So here's some standard calculators. So somebody has put in on this calculator, I actually said puttin'. They gone done put it in there, 1.26 times 10 to the little arrow, power of 3. You can keep writing that in your calculator and waste your time. Or you can understand that your calculator already has a button called an E button, engineering notation. It's the same thing as scientific. Just push the E button. All you'd have to do is 1.26 E3. The E means times 10 to the power of some unknown exponent. And so if you type this into your calculator, it's a whole lot more time saving than writing this all down and using brackets and all that other jazz. Okay? So on your Nintendo phones, it's an EE button. That's what you'd need to find. On this calculator, it's an EXP button. On this calculator, it's a times 10 to the X. So find the exponent button. Find it. Find the E, find the EE, exponent, or times 10 to the X. The best way to learn, okay, the cash money, the check mark, okay, the best way, I don't know why I put a cash money, to learn scientific notation is practice. You want to know how to practice? Make sure your calculator is set in scientific notation mode, which means every single answer you get will automatically show you in scientific notation. It would say 2.6E5 instead of 260,000. That's the best way to learn it. Practice hard, people. This is super important to understand inside and out. It's going to help you, I promise. Help me. Live long and prosper.